Gang, there are so many things that can go wrong with signal or prevent it from being received at full power or with integrity. It can get kind of daunting. You're like, will it ever get there? After working its way through free path loss and absorption and reflection and refraction and multipath issues, scattering, dealing with the line of sight issues throughout the entire Fresnel zone. Man, will the signal ever get there? And when it does, how strong is it? What we want to look at right now are ways that we measure the actual strength of the signal and the integrity of the signal as it's being received. And there's two key values that I want you to focus on right now, the RSSI and the SNR. RSSI refers to the received signal strength indicator. You can think of it as, okay, so as I receive a signal, how many bars does it have? How strong is it? How much am I lighting up this antenna as I receive a signal? It doesn't really matter how much power went into the signal. What really matters is how strong is it when I receive it. And so the RSSI is a measure of that particular strength. Essentially, it's a measure of received amplitude of that signal as it comes back in, and it'll be measured in terms of decibels. It's obtained from a signal grading coefficient which the vendor determines. In other words, there's a relative aspect that is used in terms of measuring this that is based on a vendor-by-vendor basis. So in terms of a Cisco environment, we would say an RSSI of negative 65 decibels or better for voice over Wi-Fi is an example of good quality signal. So let's say that was the received signal strength, right? Negative 65. Great. Well, the question also becomes, okay, but of that signal, how much of that was muddied by adjacent noise? See, the signal to noise ratio, or SNR, is that other value that comes into play in determining essentially the integrity of that received signal. How likely is it that that received signal is quality signal? And that's based upon how much noise is going on. Interference from what? Other Wi-Fi or Bluetooth or microwaves or cordless phones or whatever else might be generating signal that creates essentially a background noise that is always there, always being dealt with by the receiving antenna. So let's say we had a noise floor value of negative 95. So again, that's the way that decibels work. We're working from negative up toward is theoretically zero in terms of our values here. So we see those ranges. Now, the noise is at negative 95. The signal that we've received is a good quality signal at negative 65. So what is our signal to noise ratio? Well, what is the difference between negative 65 and negative 95? That is a value of 30, right? And so we would say our signal to noise ratio is 30. And generally, anything that is greater than 20 is considered a good SNR. In other words, the noise is not a problem. If I had a value here of maybe only, maybe this was negative 80, and my signal was still at negative 65, well, that's only a difference of 15, which means that a lot of the signal that I'm receiving is going to be noise. And therefore, it's going to be difficult to interpret. I'm going to have more errors, and it's not going to be quality signal as I'm receiving it. You can think of it this way. I'm speaking to you at a certain volume right now, and you can hear me. Imagine if you were listening to me, and I'm speaking at the same value, but you were in a crowded room. You were maybe at a bazaar, a Saturday market. Oh, better yet, a rock concert. I'm still speaking at the same level. Why can't you hear me? I mean, I'm talking the same level. You can hear me now. Why can't you hear me at the rock concert? The difference is the signal to noise ratio. At a rock concert, there's a lot more noise. At a rock concert, our noise would be way up here at, negative 55. You'd have a signal to noise ratio of negative 10, and you're doomed, right? You're never going to be able to get anything out of it because the noise is stronger than the intended signal. So these are some things to consider as we're looking at measuring our quality of signal as it's received by the receiving antenna. The received signal strength indicator, again, that's our top level, and then our signal to noise ratio, which essentially is used to coordinate that level relative to the noise that's around it. 20 or better is good.